We are now entering the realm of cross products. Cross products are something that you've possibly seen in math classes before, depending on what math classes you've taken. And so part of why I'm going through this is that if you understand cross products, some of what we're talking about with rotation will make a lot more sense. On the other hand, if you've never seen cross products before, it's not so important that you have mastery of them right now. They will come back in Physics 203. So the first idea is that there's two ways to multiply vectors. We met a while ago the idea of the dot product, that when you dot two vectors together, that's the magnitude of A times the magnitude of B, cosine the angle between them, and that gives us some scalar quantity, right? X and whatever you want to call it. Now we have a new thing called a cross product, which you write with a multiplication symbol. That actually gives you a new vector. So part of what makes it more complicated is that you have to determine the direction of that vector. So before you had the magnitude of A, magnitude of B, cosine theta. Now it's magnitude of A, magnitude of B, sine of the angle between them, which is called alpha for this picture, but you could still call it theta. But the direction has to come from the right-hand rule. So the magnitude is not too hard, the direction is. And so if we look at this picture, how you can get this with the right-hand rule, with a little bit of difficulty, is that you start with your fingers pointed along A, you curl them towards B, and in that case your thumb points straight up. And we'll go through some different ways to think about this, but honestly, it takes just a lot of practice of doing this and seeing it done in person to get this figured out. Here are two different ways of doing the right-hand rule. They are more or less equivalent, so it's really just the question of what one makes more sense to you. Keep in mind that you always must do this with your right hand. If you're doing it with your left hand, you get the opposite direction. So one way is to start with your thumb pointing in the direction of A, your index finger pointing in the direction of B, and then naturally once you do that, your middle finger will point in the direction of A cross B. Note that in order to do that, you want your middle finger to be perpendicular to your palm. So if you make that shape with your hand, note that there is effectively naturally a right angle between these and a right angle between these. Note that that's not always the case for A and B, but in whatever direction A and B point, you can actually change this angle to make it smaller or bigger, and then that your middle finger should still be at a right angle. So that's one way. The second way, which is my favorite, is that you start with your fingers pointed towards A, and then you curl them towards B. So effectively, your knuckles or your hand is pointing towards A, and then this part of your finger points towards B. The idea here being that if you start with your hand upside down, there's no way to curl it backwards. So when you do this, your thumb points in the direction of A cross B. So both using your right hand, these are actually going to be equivalent. They give you the same direction. Use whichever one makes more sense to you. Sometimes students tell me they have some other way of doing the right hand rule. As far as I can tell, that's usually doing it with the left hand and incorrect. So be careful. If you've learned a different way of doing it, possibly that's right, but make sure that it agrees with these directions. So cross products depend on the angle, and let's talk through what that actually looks like. If A and B are parallel, their cross product is actually 0 because the angular difference between them is 0, and remember that this was sine of alpha determining the magnitude. This is obviously opposite of the dot product, where this would be maximal dot product. In the case of the cross product, it's 0. Once we have some angle that is not 0, we now have some result for A cross B. Sine of 30 is 1/2, which is why the length at this case of the result is 1/2 A times B. Then when you get to 90 degrees, it's maximal. And in this case, the direction is the same, right? The right-hand rule always gives you the same direction based on the plane that these two vectors are in. So we have changed the direction of B, but the right-hand rule gives you the same one, the same resultant direction. But now the magnitude is bigger because you have 90. Sine of 90 is 1, so the length of this is A times B. So this is just a little bit of how to think through this, and even if you haven't mastered all of cross products, this is really helpful. A few miscellaneous things to state. When you reverse the direction of the cross product, you actually get the opposite vector. So this is one reason why it's really important to be careful what you write down, because if you write down B cross A, that actually should give you the opposite vector than A cross B. So doing that, obviously the magnitude is going to be the same, the angle is going to be the same, the right-hand rule just flips around and gives you the opposite direction. Another thing is that our unit vectors actually cross product into one another. So x cross y equals z, y cross z equals x, z cross x equals y. And this actually defines the right-handed coordinate system. This is how people know what direction z must be if you've already defined x and y. So this is just something helpful. And again, if you meet cross products within a mathematical sense, you'll see a lot more of this because a lot of proofs depend on this idea.